Hello and welcome to another LabScope video. My name is João Abreu and today we are going to talk about delta optimization. So first of all, delta lake. What is a delta lake? A delta lake is the optimized storage layer that provides the foundation for storing data in tables in the Databricks Lakehouse platform. And the delta lake follows this type of architecture. Basically, you have got data entering in the stream or batch format, and inside the delta lake you have got three different layers. The first one, the bronze layer, where you've got ingestion tables, the silver layer for refined tables, and the gold layer for feature and aggregate data store, where we have got data ready to be ingested by analytics and machine learning processes. So the first process is partitioning. Partitioning separates data into different folders in the blob storage, thus reducing the volume of accessed data when querying. Common partition fields used are data type columns or source identifiers, and when partitioning you need to watch out for excessive partitioning that can lead to a slower read from the delta lake because the driver will load data from many different small files. So it's important to find balance in partitioning, and you should choose partitions with more or less 1,000,000 rows per partition. And here I've got an example command for creating a table using a partition by date, and also a little print screen from one of our blob storage where you can see all the folders, each one representing a different partition by date. Next we have got optimize, and the optimize command optimizes the delta lake layout, compacting and removing unnecessary files from the transaction log. Doing this without changes on the data, returning file statistics for the operation, and on the other way starts up many Spark jobs in order to optimize the files. So here I've got an example command for using optimize. You just write optimize, the table name that you want to optimize, some conditions that you can add, and also the zorder command that I'm going to talk forward. So optimize uses bin packaging, and bin packaging aims to produce evenly balanced data files with respect to the size on the disk, but not necessarily the numbers of tuples per file. However, the two measures are most often correlated. So this optimization is idempotent, meaning that if you run it twice on the same dataset, the second run will have no effect, and it's going to be faster. And now, Z-ordering. Z-ordering is a technique to place related information in the same dataset of files. It aims to produce evenly balanced data files with respect to the number of tuples, but not necessarily to the data size on disk. The two measures are most often correlated, but there can be situations where that is not the case. So Z-ordering is not idempotent, meaning that you can run it twice on the same dataset. The second run is not going to be affected, but that doesn't mean that it's going to be faster. And now, which fields should you choose when Z-ordering? Basically, you should choose columns with high cardinality, for example, merge keys, and you need to know that when you specify multiple columns, you are going to lose effectiveness. And now, Z-order has got a problem, and the problem is that Databricks only collects statistics for the first 32 columns defined in your table schema. So it's going to be ineffective if the columns that you choose do not have statistics and are not present in the first 32 columns of that same table. You can fix this by two ways. You can reorder and rewrite your table, and placing the columns that you are using in Z-order in the first 32 columns and have statistics for that. Or you can use this command and apply it on Databricks, and you are basically telling Databricks to store the statistics for all the columns in your table. So how often should you run optimize? It depends. You should run it more times if you want better end-use query performance, and run it less if you want to optimize the cost. Just don't run it in static tables. And here I have a small print screen of one of the processes that we used before applying optimize and Z-ordering. And this notebook is basically searching all the tables in our database and choosing the tables that have merge key, and checking if the merge key is present in the first 32 columns, and if that is not the case, it's going to rewrite all the table and placing that same key in the first 32 columns, so that forward we can use the ordering and optimize in an effective way. Thanks for watching, don't forget to like and subscribe, and stay tuned for more content.